Hello everyone, this is Gil Rossmiller with Colorado Code Consulting. Today we're actually going to take a look at a few pieces of commercial HVAC equipment, and hopefully I can give you at least an overview of how they work, and that there really isn't a whole lot of mystery to these things. They just get really big. Here we have a picture of a reasonable sized makeup air unit, right? Makeup air looks like number one. A little electric disconnect here. Essentially, it's just a great big heater. So this is several hundred thousand BTU. So it's just a giant furnace. So it's a makeup air for perhaps something like a large kitchen hood, putting exhausting air out, and this is what's providing the air so it can suck it out. Just gas fired right here, hooked up to your gas line. So it's just like your furnace at home, right? The fire starts up and goes into the heat exchanger, and it just moves air through it. Just bigger. So what we have here is a fairly large evaporative air system. So essentially this works just like it would on your house, that little box on the house, yes? So what you have is a watering tray up here, so where the water is entering the media filters. And so the water then drains down through the media filters, and air is pulled through these. And when the air is pulled through there, it does a couple of things. Makes that warm air that's outside a little cooler, but it also makes it wetter, so it makes it more humid. These types of systems work exceptionally well in dry climates, like Colorado, for instance. Wouldn't work so well in places like Florida. Yeah, would not work there because, of course, the air is already very humid, very moist. And so, yeah, does it work? You bet. Does it cool the place? You bet. The disadvantage, of course, is it makes things very humid, very moist. In this particular case, this is what they wanted, so it kind of worked out. Once the any extra water then just drains down into the drain pipe and is carried away. In the next slide, we'll see some louvers that actually control the amount of air. Unfortunately, I don't have any pictures of the fans that actually create the flow through there, but we'll take a look at the other end of the building. So here we are on the other end of that building, and so what these are, we've got very large and placed motorized dampers. Okay, so all these these louvers then open and close. They're nicely sealed. We've got some control wires here, or wires that give us information. So it might be airflow and what the humidity is, or how dry the air is. It could be measuring that. But the beauty of it is that they're able to open these up and then control the amount of air that's coming through and then getting filtered through the other side of the building. So it's nice because they've got ones up high, right? Heat rises, so they can just ventilate up there, ventilate toward the middle here and ventilate toward the bottom, or open up all those bad boys and move all the air through the building. So they can do that by controlling with their little thermostats here, not really thermostats, but control wires to give them information, data, what's happening with the air. So nice little system. Yeah, it's a greenhouse that's here, and so yeah, they're growing stuff in there. So what we have here is two fairly healthy sized boilers. That's what these are. And these are not horribly efficient. These will probably be 80%ers because we've got very large vents up here venting all our hot gases. And clearly we're still under construction here. We've got welding tanks sitting next to it. But we've got our regulators here. So this is our gas line, fairly healthy sized gas line coming in to feed it, sucking in combustion air, blowing into it. And all these little pipes here are going to be vents. Looks like it's the vent for the regulator. So these are vented type regulators that get vented out. That's probably a pretty healthy sized one. So these work just like any other boiler. The one you have in your house is maybe 100,000 BTU. These bad boys are probably over 1 million BTUs. Again, works in the same principle, same pressures, just a whole lot bigger. And this could be used for heating, or this could be heating for domestic hot water, right? Not really sure. Can't remember on this particular picture. Now these are also boilers, and fairly healthy boilers. But these are fairly new and very high efficiency. These will be condensing boilers. All these pipes, all their vents, nicely insulated going out. Looks like we've got supplies and returns here. It's hard to tell from the picture angle here. But this is all insulation, all insulated in all of the pipes that are providing the hot water through the building. So quite a big difference, huh? Between those two. The ones prior to this looked ancient, did they not? Relatively speaking, and they are relatively, but you can still buy them. Still buy 80% boilers. But these are probably closer to, can't remember, these are probably over 95%, 96% efficient. So these are really nice pieces of equipment. In this particular one, we've got some fairly healthy pumps. Okay, these are all pumps. That's what all these are. And they must be moving some real liquid here. We've got them on some nice isolated pads here. We've got nice flexible joints here. When these bad boys are moving, they probably vibrate. So this probably is a hot water type system. I'm guessing, I can't remember where we took this picture at. Pressure tanks here. But this just kind of give you an idea of some of the size. I mean, if this is a hot water type system, some of the pumps that you'll see in your house are probably about the diameter. Let's see, well, I know they're probably about the diameter of this insulated pipe here, probably even smaller. You know, they're about 2 inches in diameter, 2.5 inches in diameter. You know, these are reaching a foot, right? Yeah, these are real pumps. It's good stuff. And so what we're looking at here is something that you might even see in your house, although this is a commercial application. We've got lots of zones. So this is basically hot water heat. That's what this is. So we've got all the brackets. So what all of these are the brackets that are all holding the pipes to the walls. And the reason they're big like that is because you'll see in the next picture, this is the insulation. It'll all come quite clear when we see the next picture. So we've got the supplies and the returns. We've just got ball valves here. Right now they're all turned off. Yeah, we're in the middle of construction here, clearly. These are the zone valves here. So these are the thermostat wires, the control wires that will all get neatly bundled and over to the controls. But this is the valve that will open and close the loop. So each one of these indicates a different loop or a different zone that's providing the heat. That's why they call it a zoned system. So it could be baseboard heat. This could be in-floor radiant heat, and it could be different loops in the same room. Not generally, but it could very well be. But typically, this will be just different rooms, different spaces. And that's what makes that hot water heat so nice, is that it not only is a nice radiant heat, it's heating the objects in the room rather than the air, but it heats very slowly. That's how it works. But once it reaches that temperature, it is very nice. It stays very consistent and doesn't take a lot to keep it warm, because if it's in-floor radiant heat, what's it doing? It's heating up the floor, especially if it's in a layer of concrete. Yeah, you got quite the heat sink there. Heat mass heat heating up that concrete. So this is kind of what it looks like under construction. And the next shot, we'll see more what it looks like when it's all said and done. So here's another shot. The same, almost the same exact position, clearly still under construction, but you can see it's all nicely insulated now. Okay, all of these zone controls, nice piece of flex, right? All neatly tied back into the control valves, easily seen, easily worked. And you can see these clamps. This is what was all, right, holding everything together. You can see this is just one of the small systems. You can see we have some fairly healthy pipes right on here. But this is what, this looks like a nice job. Well insulated hot water heat or hot water piping system. Nice, neat zone valves, neatly done. This is a good looking job. Well, it's a little messy right now, but they'll clean it up. So here we have kind of a standalone dehumidifier. So you'll see this in places that need extra dehumidification. Swimming pools would be an example. I don't know, doggy daycares might be another example. Where you've got a lot of pets and a lot of moisture, and so the air conditioning system itself won't handle it because, well, I don't know. Do you want to run air conditioners inside your pool, right? Well, no. Generally, you want to keep those pools nice and warm, don't you? Yeah. So the idea here is that this one clearly is still under construction. I got some arrows here, but yeah, this is the little pump. Condensate pump. Clearly, you don't have a condensate drain. I don't think it's for this particular unit. But essentially, the air is coming in where that arrow's at. It, all right, circulates down, and then goes through, gets all nice and dry. So essentially, it's got refrigerant. It's like a little air conditioner. So it's hitting that cool coil. That warm, moist air hits that cool coil, condenses, yes, and then gets recirculated back into the unit. Yeah, so it's kind of cool. Yeah, the ducts in here, I can kind of see it back here, but there's gigantic round ducts on the other side that you can't hear. That's what's supply, that's the supply and the return for this particular unit. So standalone dehumidifier. So here, what looks like, it looks like a regular old kind of a residential style furnace, yeah? What this is just an air handler. So you may have heard that it's just an air handler, a lot of air handlers, but all it is a great big fan. And then you install coils, and this looks like it's just for air conditioning. So we've got our refrigerant lines coming in here, our condensate drain, coming out and over to a floor drain, I'm certain of it. Great big filter here, yeah. So you got your return coming down, coming up, goes in, gets conditioned and dehumidified, all right, and then comes up into the supply air. Again, these have got large round ducts that are going through the wall there, but it's essentially a standalone air handler with air conditioning coil. These are the types that you could also have coils in here that actually reverse. So if this was connected, let's say this was connected to an air source heat pump, what would happen is if this ended up getting reversed, and I can't remember if this was a heat pump or not, it would be heating then. So in the summer it would cool, and the beauty of a heat pump is it has the ability to reverse that refrigerant flow. So instead of rejecting the heat to the outside, it rejects the heat to the inside. So it becomes a heater. Yeah. They're very clever. Heat pumps are great. They're limited on how cold it can be outside and still produce heat on the inside. Yeah. So places that don't have a very low outside, low winter design temp, you can get away with that. If you've got a winter design of 35 degrees or 40 degrees, you can get air source heat pumps that'll heat that, no problem. But anyway, air handler with just an AC coil in there. So not so different, but basically this is an air conditioner. It's a condenser for commercial type application, maybe for like a computer room, for instance, very specific for that, clearly under construction, but nothing fancy with this particular piece, just the way it looks, right? Works just like your air conditioner at home. Nothing fancy there, but just thought kind of cool, nice little unit. Probably does a room or two. All right, so these are pretty cool things. This is a variable frequency drive. And you're thinking, what the heck is that? Well, it's a really fancy motor control. Okay, so it does a lot of different things. It controls the speed of the motor. It protects it against overcurrent, like during ramp up, like when the motor's ramping up and when it's slowing down. You've got braking abilities, power boosting abilities during the times that it's ramping up and ramping down. The other thing that's really nice about it is that during startups, electric motors really take a lot of energy when they want to start to turn. And these things really help so it doesn't pull a whole lot of excess energy, electrical energy, clearly, when it does its startup. Okay, variable frequency drives you can get on this. This happened to be in a system, and I really apologize. I should have taken more pictures. These were controlling air handlers that were basically the size of your living room. Okay, the doors in these things were the size of your front door. Okay. The trunk lines and the ductwork that led to the equipment that these things control were huge. Fan walls. When you have very large systems, again, I wish I'd taken a picture of it. Just imagine a wall, instead of one great big fan, it's a series of much smaller fans. They almost look like a regular box fan that you put in your bedroom, right? A box fan, you buy it at Home Depot, but it's a whole bunch of them. There might be 30 or 40 of these things, and it literally makes a wall of fans. It's what they call a fan wall, yeah? The beauty of that is that very easily controllable, right? You're not trying to start this gigantic motor for a gigantic fan, right? You're starting a whole bunch of little ones. Plus, if one or two of them happen to fail and need maintenance, it's not like the whole system goes down. So it's very clever, and I wish I had, and I truly apologize for not being able to do that for you. But that's what these are. Variable frequency drives. They come in all sizes. These are fairly healthy, but that's what they do. It's pretty cool stuff. Very energy efficient and required in certain sizes. And generally speaking, people that are putting in those larger units, they're going to have variable frequency drives, absolutely. Yeah, this was just a fun picture I took. This was something that was outside my hotel room, I think, one place. I thought, wow, there's a lot of equipment on that roof. They're just big, giant HVAC units, heating, cooling, right, ventilation, great big outside air intakes. I'm pretty sure that's the air intake, absolutely, and this will be kind of the exhaust. When I say exhaust, I mean pressure relief. So when you've got the economizer in these things that open up and you're sucking in nothing but 100% outside air, you don't want to overpressurize the building, right? And so you've got these big hoods that's relief air. So if you happen to be standing by one of these things, when those things are, the economizer's open 100%, yeah, there's a lot of air moving out of here. Yeah, the return is just through there. And we actually will show you a video here in a little bit of an air economizer working. I know, it's kind of a mystery, isn't it? Yeah, but they're fun. But yeah, these are just nice big units and kind of cool. So here we're on a rooftop of an actual existing building, commercial building, where they've actually replaced pretty much all of the rooftop units. For the energy code, we need to make certain that all the new rooftop units actually meet all the energy code requirements. So hopefully during our plan review process, we got all the new equipment that's going to be supplied. Now when we're here on inspection, we're actually trying to verify did they actually put what they said they were going to put, and we got through our plan review. So we can start with this model number here at the top.
And sometimes that's a really good indication because you might get lucky and the model numbers would actually match. I usually don't get too bent out of shape with the whole model piece of it because the model numbers change like they change their bathwater. I mean, it seems like every time they change a color, they put a new number. So what I am looking at mostly is what will it actually do? What are my capacities? So we look down here and we actually start to look at our heating capacities. Does that match what the plans say? We can come down here to our cooling capacities and it'll tell us what our cooling capacities are. It tells us what our efficiency is, and it will do the same thing up here when we're looking at the heating capacity. In this particular case, we got 150,000 BTU input, we have 120,000 BTU output, and it is at 81% efficiency. As long as those match our plan as far as the efficiencies and the capacities, I don't get too bent out of shape about the model number.
So the economizer is really just a great big damper. It just opens up. Really all it is you hear the word economizer and I think some people think, ooh, what the heck is that? Pretty cool, huh? Nah, it's just a damper that's opening. That's all it is. All it is a damper that opens up, and within the unit itself, it is now sucking the air, 100% outside air. And the reason that's good is because it's free air conditioning. That's where it comes down to. So for places like Colorado, where it cools off dramatically at night, yes, yes. Why would you use your refrigerant, right? Why would you turn the air conditioning on if you want it 70 degrees inside and it's 65 degrees outside? Why run the air conditioning? Just bring in the outside air. It's all filtered. It goes through the same filters and all the stuff that, when it works during the day. So these things are cool. And as you can see, they're really not, that amazing. I mean, they're amazing, but it's just a damper. It's just a damper that opens and closes. That's an economizer. So here I just wanted to try to give you an idea of what was inside a kind of a typical rooftop unit. So here on the right, I don't know if you were looking at my residential one, that's the coil inside my furnace. That's a residential coil. So this is that same part in a rooftop HVAC unit. It looks different, but it's the same thing. It's got a couple of different compressors in it. We'll see pictures of that, a couple of different circuits in it, and that is what you think it is. It's a filter. Yes. That hole in the ground where you see the pallet in the background, that's, where do you think? That's going to be where the return air is getting sucked in. Yeah. So this is the return air duct, right? Clearly not fastened to anything yet, but that's all it is. And you can kind of see, you can kind of peek here. What does that look like? Those of you that are familiar, that is the heater. Yeah, that's where the gas is and where the heat exchanger is going to be for the heat. So here's the air conditioning, and there's a piece of the heater. Well, we'll get a close-up of that here in a second. But it's just bigger. That's all it is. Just bigger. This is probably I don't know, 5 or 10 ton unit. But it just moves air just like it does in your house. It just is bigger. All right, so here's that shot of that compartment, right? And so for those of you that are familiar, there's your gas valve. The gas comes in here, shoots in here, and this is where the flames. So if we were running, we'd be able to see the flames in here. Then the air then is passing through this chamber where the heat exchanger's at, and this is the vent. That's just like the fan for the vent, right? Just like it'd be on your old furnace. And this is an 80%er. This is not sealed combustion by any means, but it works. It works just like the furnace at home, just bigger. Again, this is probably 150, maybe 300,000 BTU piece of unit, but that's what it looks like on the inside. No real mystery. All right, so what we have here is, you can recognize this, that's what sits outside your house. Well, if you were to take this bad boy apart, you'd see stuff like this, compressors. You got a couple of compressors in this one. You got your refrigerant lines here running through the compressor. And here, see we got our refrigerant lines kind of connect into there, don't they? Yeah. And so here is our little condenser. So the refrigerant gets cooled here. So if you were to pull the screens off of this, this is what you would see. Okay? Air is getting pulled through here, and that is what's dealing with the refrigerant that goes back inside your house, the ones that we just looked at, and actually makes the house cool. It's the refrigerant cycle, a beautiful thing. Yeah, but that's it. No real mystery, just bigger, more of them, but works exactly the same way. All right, so this is a small chiller. And so we can't see inside here. Yeah, they were still under construction, taking things apart on the job sites, not looked at really fondly. But it's essentially a refrigerant cycle inside here. It's got it all. Evaporator, the condenser, everything is in here. And what it's doing is chilling water. And so in this particular case, we're piping water into the building to cool it. Yes. And so what these are, right, is pulling air through here to do our thing with the refrigerant. That's exactly what's happening here. So this isn't a gigantic chiller by any means, but it is cooling what they need to cool. So whether it's computer rooms or whether it's just cooling for folks, machinery maybe that's going on inside there, and they want cold water. So cold water goes in, goes through a VAV box, air is moving through it, and cools the air. Warm water comes back, gets chilled again from the refrigerant unit, goes back into the building. It's a never-ending loop. So yeah, that's a chiller. Yeah, that was kind of quick. Hopefully, it's just 20 minutes or so of just a few pieces. Hopefully that provide a little light on some of these commercial type equipment. Gil Rossmiller again, email me. Get questions, energy related stuff, code related stuff, don't hesitate, give me an email. That'll be good. And thank you to our wonderful sponsor here, Xcel Energy, for finding the funding for this series of videos. Catch you next time.